So, sort of getting arranged here to do some more recording for a special video that I'm doing for a friend who promised it for next week when she gets home, and hopefully we'll be able to stick with that. Fingers crossed. But in the meantime, I thought I would, I've made some tea, or I'm getting ready to make some tea. I thought I would just do another tea video really quick. So, a friend recently asked about blood types, or had posted something about blood types, and it's something I know something about. So, thought I'd share a little bit about that. Also, I have a couple other things to share. First is that I got a new teacup. I'm laughing because I'm whispering it because I mentioned it to my husband, but he doesn't really know how big it is. And I know that he's been a little bit stressed. Stressed isn't the right word, but there's not a lot of room in our tea cupboard, and I keep acquiring things and putting them in there because teacups are almost as fun as coffee mugs, and he likes having a matched set of coffee mugs, and I like having lots of different ones. So same thing with teacups. Anyway, it comes in a box, and you can see there's a fox on this box with some winter trees, because foxes are best in winter for some reason. Although I hate winter, which is funny, they live in Maine because we have 8 months of it. So you can see fox here with some trees in the background in this nice cardboard box. In the box is a teacup with the same picture on it. And it's a very large teacup. You can see how it compares to my hand. It's quite large. This is from a place in close to my house where they sell all sorts of kitchen goods, and I stop there with some frequency to get ham and Swiss and butter on brioche. I think that's the name. It's called ham brioche. I think brioche is the name of the roll, which is sort of like, if you haven't had one before, it's almost like a sticky bun in its shape, but it's not as sweet as a sticky bun. And it's sort of like a croissant in the way it tastes. It's very buttery and delicious. And at this place, they take very thinly sliced ham and very thinly sliced baby Swiss, and they put them together, and they put some butter on the brioche, and they sell these for breakfast. So I stop on my way to work sometimes and get it, and it's really, really good. It used to be just a treat, but I gotta tell you, it's become more frequent recently, probably more than my budget can really handle, but sometimes I tell you, when I'm driving in the morning, it's just the right place to stop. Anyway, there's also this little fox head right here on the inside of the cup. Now, I washed this cup out already, but it looks like it got a little bit of dust in it while I was waiting in the box for me to start the video. So I'm going to wipe that out. Alright, so that's my new cup. And then I'll just move this over here. Put that over there. Today for tea, I have a new one that my little son really wanted to get because of the name. It's called Dragon's Well. It's a green tea. The ingredients in this tea are green tea. It does not have much caffeine because it's a green tea, and it says the antioxidant level is very high. I don't know why, I guess that's just a green tea thing. The description on the front says it is one of the most popular teas in China. Its hand processing and pan frying creates the signature flat shape. It has a chestnut-like flavor with a hint of sweetness. Well, I'll tell you, I'm not really a fan of chestnuts, but I am a fan of my little son, especially when he wants to try new things, so we try to encourage that. So let's see what this tea is like. I do like green tea too. I just prefer something slightly more floral, but let's see. Pan frying, huh? It smells like tea. There's nothing particularly remarkable about it. Let me get a tea bag. The usual tea bags. Compostable. I'm running out of them though. I'm going to have to get more soon. There we go. Okay. Alright. Switch to use 1.5 teaspoons. So I think I will just do like a half a tablespoon, which would be a little too much. It doesn't steep for very long either, so I'll show you what it looks like. So it's very, see if I can get that in there, very flat. And so I think I've shown you the gunpowder green that I have. Gunpowder, it rolls up really tight into little tiny gunpowder shapes. They're not really gunpowdery, but and then a regular green tea is maybe a little bit more kind of chopped up looking. It stringier looking. This is very flat. So I'll just put this over here. Dragon's Well, huh? That's interesting. The word for dragon in Chinese is Long. So, Wulong tea, it's a very common tea. I think it's a common tea. I believe means black dragon. I might be wrong though. Wu means 5 as well as black. No, wait a minute. I'm wrong about that. Wu is 5, but black is hazel. So I don't know where I got the notion that I meant black dragon. Unless maybe there's another word for black, which is possible. I mean, we have lots of words for black, right? Onyx or ebony or whatever. Wu also is to dance, I think. Could be a dancing dragon tea. I don't know what the characters look like, so I don't know for sure. Sometimes I think I should probably do more research before I record these videos, but you know, you never know when you start speaking off the cuff what's just gonna blurt out of your mouth. Alright. Things are a little precarious over here. I have a stack of items for video later. Okay. My tea. And then I still have my gooseneck kettle, which I kindly had already heated the water in because it is surprisingly loud. That's what you get when you get a bunch of molecules knocking around in a metal container. It does make such a nice sound, though. I really like that water sound, that pouring sound, better than the other kettle. Okay, the other thing I'm going to do today is, in my unboxing video, I had a friend send me some things in a box. And one of them were these Sharpies. And I was going to open them. I haven't opened them yet because I was worried I was going to lose them everywhere. But I think this is a good opportunity to add a little color to these videos. So I'm going to open them up and use them for my illustrations, at least in this video. So I'm hoping this isn't going to be too noisy. But I'm not sure actually how to. I also have a meeting in 20 minutes. Yeah, those tearing sounds will sound hopefully not too loud. I hope I am completely satisfied because I just tore through the part that told me what to do if I am not completely satisfied. Alright, I think I can get to them now. So, alright, but the tea. Green tea only steeps for a few minutes. So it's probably already ready. Alright, let's try it. It smells like green tea. I can see the chestnut. It's not unpleasant, but it is a bit nutty. It's a little more woodsy feeling. Green tea I tend to think of as like it's like a pasture or a meadow. Things with tender green shoots. This has more, this feels more like a place with bark than sticks, but nice. It feels very early summer. I don't know, it's almost got a muddy sort of feel to it. Anyway, okay, so I was going to talk to you today about blood types. It kind of goes along with, we've talked about genetics before, Mendelian genetics, and I did another one on inheritance, I think, and one on what actually DNA does. So, actually inheritance was the Mendelian one. So, when we talked about Mendelian genetics, we talked about pea flower color, pea plants, and used a very simple example of purple flower color being the dominant gene, the dominant allele of a gene, the flower color gene, and white being the recessive color. So, probably not too surprisingly, reality is a little more complicated than that. Mendelian genetics looks at primarily when you have one dominant and one recessive gene, but genetics is more complicated. So what I'm going to do is pick out, let's do this green one here, this color, and this color, and hopefully you are not, you don't have color issues. We'll tell you what they are anyway as we go along. So this would be just to enhance that. And it would be good if I had a purple would be good. Ah, here we go. Brown. Brown is boring. Brown is good boring. Okay, so let me set these aside. Hopefully it will stay there. Okay, so I lost my thought there. Oh, we were talking about, yeah, so I usually have just 2 alleles when you're first talking about genetics, because it's simpler to describe. But genetics, just move this over a little bit. I think I'll probably leave this in because it's kind of a neat sound. Me moving my little table over. Oh, I don't have room. Okay. Very quietly setting that down. Shh. Okay. So, let's go in a little closer. So the thing with Mendelian genetics is, as I've said probably 3 times now, you look at just 2 copies of an allele, and one's dominant, one's recessive, and it's fairly straightforward to explain how it works. With blood type, it's a little bit more complicated. There are actually 3 alleles instead of 2, and so you don't end up with that nice 3-to-1 ratio because there are now 3 instead of 2. And we have 2 alleles that are codominant. So what you look at when what you see. That's a good note to myself about making a video about blood types. So what you see with blood types, and this is probably familiar to you, is that you can have type A or type B, or you can have type AB. You can also have type O. So the alleles are A, B, and O. The way these are designated, okay, this combines with the other video about what DNA actually codes for. What do we talk about when we're talking about genes? On the surface of your red blood cells, your blood, which look like little flattened discs. They're like, I'm trying to think if there's a candy like that. If you could squeeze in the middle of a spree or something, they're flat discs that have a pinch in the middle, unless you have something wrong with them. So they're usually, when we draw them out, we draw them something like this. It has a thick band around the outside and it's kind of squashy in the middle. This is not important to this discussion at all, but when we're talking about blood type, there are 2 proteins that can be produced by your red blood cells. I think they have identified what these are, but we still use these old designations because it's easy, shorthand. So you can produce what's called the A antigen. And antigen here, I'll write that word down for you. Antigen is actually shorthand for antibody generating. So it means a protein that can cause your body to generate antibodies against it. Antibodies are part of your body's immune system. So when you are fighting disease, you generate antibodies to that particular whatever. Viruses are tricky because they do things like inject themselves into your body cells, which makes it hard for your body to recognize that there's something wrong with it. Although some viruses do produce proteins that are then expressed on the cell surface. I'm using a lot of words. Sometimes viruses make stuff that gets pushed out through the cell wall, so it will stick out so your body can see that that cell is infected. I'm getting far afield here, though. With bacteria, for instance, bacteria are small cells that cause disease, so your body recognizes their proteins on their surface, these antigens on their surface as being not part of your body. So they'll grab onto them. And as part of the immune response, maybe I should make a video about that, you'll create antibodies that will grab onto these proteins to say, we found one, this is not part of our body, you need to destroy this. So then your white blood cells, which are your immune cells, amongst others, will be able to grab them because they grab the antibodies and whatever's attached to them and chew them up. Anyway, in your body, if you are type A, if you have blood type A, you have these molecules, surface molecules, but your body doesn't produce antibodies to them. It's a natural part of your body. We still call them antigens because if this blood, if you were type B and you had type A blood donated to you in a transfusion, your body would generate antibodies to this protein. And that's why it's so important to make sure that you have the right blood type when you are having a transfusion or an organ donation, for instance. Organs, they actually have a few more proteins they need to match on, but blood type is one of them. Okay, so surface antigens. Surface meaning on the outside part of your body cell, in this case a red blood cell. You can also have, as you might guess, the B antigen. That's a different protein, but they're codominant. That means if you have both of these, both of them are expressed. And then the other allele is actually null. So there's not, technically, there's not an O antigen. It's just that you don't have it. These are written usually as I. So actually, let me do that with do it in color. So you can have I, little I. That's type O. Means you don't have A or B. You can have A, which is written as big I, and you may remember from the other video that we express dominant alleles in using the big letter. So there's I with a little a to show that this is the A allele of the blood factor. Okay. There we go. Okay. And then you can have B. Okay. So big I because it's dominant, and a little b to show you that it's the B allele of the dominant gene, of the I gene. Okay. So let me color these in. So you may recall from the Mendelian genetics that you can have 2 copies of these alleles, which means you can end up with, 16 different blood types. I have to write it out. I'm going to write it out in just a minute. You can either have 2 I, little I, which gives you type O blood. You can have a little I and a big A, or you can have 2 of A. Okay. Or you can have a little I and a big B, or 2 big B. Or you can have a big B and a little b. Big A and a big B, or the other way around. I think I've done this right. Let me just make sure. Okay. So like this. There we go. So the thing is that it doesn't matter what order you go in, so this would actually be considered the same genotype. Genotype is which copies of the alleles you have. I'm not sure if I explained this before, actually. phenotype is the expression of your genotype. So phenotype is what you see. So genotype would be for blue eye pigment. Blue eyes would be your phenotype. It's manifested as your blue eyes. So I don't know if I'm going to mention that again later, but there you go. There you have it. So we have type O. We have type A. We have type B. And actually, let me use one more color for type AB. Actually, no, I won't. I will mix it all together. Type A and B. Okay. There they are. Inglorious Technicolor. So, type O is the most common blood type, is that right? Is that true? Or is it AB? I never remember which is which. I have AB, but I have AB negative blood, which is why I know things about blood type. It's important. I'll share that with you later. But you don't have either one. So type O cannot receive blood from any of the other blood types, because if they do, there's a surface antigen, a molecule that their body will react to. Type A has the A molecule, type B has the B molecule, and type AB has both. Type O has none of them. Type O is for no. No, don't have it. Type A, you can have one of each. You can have a null one or 2 copies. Type B, you can have a null one or 2 copies. Type AB, you have to have one of each. So, type AB can receive blood from type B because they have the B molecule. And they can receive type A blood because they have the A molecule. So type AB is called the universal recipient. They can receive from O, A, and B because they have all of these, or none. None, if there's no molecule to react to, there's no molecule to react to. So all of the things that their body could produce an antigen to, antibodies to, are present already. So the body won't react to it. Type O doesn't have any of them, which means type O can be given to type A or type B or type AB because they don't have any surface molecules to react to. But it also means that they can only receive from type O because there are no surface molecules in this blood. There's nothing to react to. So they are called the universal donor. AB can get from anybody, O can give to anybody, but can only receive from type O donors. I just refer to myself as AB negative. So negative is the Rh factor. And it can be positive or negative. So you'll have people say they're A positive or A negative, for instance. I'll get to that in a minute. That's a different blood factor. These are like the base blood types. And Rh positive or negative comes from a different thing. So, where was I getting with this? Okay, so the other thing is that you can use this, as you can see, if you had parents, for instance, that had, just remember the word heterogeneous. They were heterozygotes. That means they had a copy of the dominant gene and a copy of the recessive gene. In this case, a copy of the null gene, allele, the null allele. And you had one that was type B. Then you can end up with AB. Or you could end up with B or A. But you couldn't end up with O unless you had, unless you had the other parent had also a copy of the null gene. So it makes the genetics interesting. I draw out a chart, but the whole reason for doing this video in the first place was to talk to you about the Rh factor. It's just that this is interesting because it has 3 different alleles, so it makes the genetics a little more complicated. Okay, so we were just talking about surface antigens, the molecules that are on your red blood cells in your blood, in this case, and how that determines your blood type. Another thing I wanted to talk about, and actually the primary thing I wanted to talk about, was Rh factor. So Rh, if I'm not mistaken, and it's possible I am, because like I said, I didn't actually sit down and do research before I did this, so take all of this with a grain of salt. This is from my memory of this stuff. And I've noticed that I misspeak quite frequently, I use the wrong vocabulary sometimes. So Rh factor comes from, I believe, rhesus monkeys, which are also known as macaques, for endless jokes. Rhesus monkeys. I believe because it was first characterized using rhesus monkey blood. I don't know. Could be. Rh for rhesus. And it can be positive or negative. That means either you have it or you don't. So like with blood type, where type O represents a null allele, it's truncated. It doesn't have a component that goes above the surface of the cell. Rh factor is similar. If it's negative, you don't have that part that your body would recognize as a foreign agent. If you're positive, you do. So I'm going to draw this blood cell again. And I'm going to put this thing on it, and it's going to be Rh factor. You have a big blob sticking out like that. I think it's on blood cells. I'm pretty sure it's on blood cells. I'm not an expert with blood types. Just know a little bit about it. So, and then you're Rh positive. Okay, so this is Rh positive. I'm not. I'm Rh negative. I don't have this factor in my blood. So the reason this came up is because we were talking about Rh sensitivity, and there was some confusion about how blood types change, and it's a misunderstanding of how your body interacts, particularly how a mother's body interacts with her fetus's blood type. So your genetic code will make it so you always have the same factors on your blood cells. That doesn't change. So you can't go from being AB to suddenly being just type A. It doesn't happen. It's possible that you could be tested, have your blood type tested, and have the test be funky. You know, things don't clot. They do it by clotting factors to see if your blood reacts to antibodies. So they do it that way, and it's possible that sometimes that test doesn't work right. So you might have had the experience where somebody said you were type A, but it turns out you were type AB, or something like that. But that's why they always test your blood several times if you ever need a transfusion, just to make sure that they absolutely have it right, because if they give you the wrong blood, it's a problem. Anyway. So I'm going to back up a little bit. I'm going to tell you a little bit more about the immune system. And so I told you before that those surface antigens for A and B, we call them antigens because if they're not native to your body, then you'll produce antibodies to them, which means that your body's immune system will react to them like they're a foreign agent. So, here I've made this Rh positive, AB positive. This is not me. The interesting thing about this is there are different kinds of antibodies. Antibodies formally are part of a class of proteins called immunoglobulins. I'm going to write that out. Okay, so immunoglobulins, which are immuno meaning to do with your immune system, globulin meaning lump of globs, like you'd expect, the glob of protein. These are often abbreviated as IG, and they come in different classes. And A and B blood type surface antigens are IgM, I think, in the M class of immunoglobulins. But Rh factor is in a different class. Antibodies to Rh factor are in IgG, I think. So this is actually, the reason why this is important is that IgM does not cross into the placenta. So it doesn't, if you're pregnant, these immunoglobulins don't get into where the fetus is. IgG, on the other hand, do. So why that's important is if you have Rh negative blood, like mine is, I'm gonna put a big X on that. So let's say I'm Rh negative. I have Rh negative blood. I don't have this molecule in my body, which means that my body will produce antibodies. It will produce IgGs. I hope it's G, whatever class it is that these are, that crosses into the placenta. It will produce those it will produce antibodies to Rh positive. So Rh positive, it's like any other genetic inheritance, and I don't remember if positive is dominant. I'm pretty sure it is, because it's only 15% of the population has Rh negative blood, a very small percentage. So if my husband, for instance, doesn't have to be husband, whoever gets you pregnant, or whatever gets you pregnant, has positive blood, and I have negative blood, then the baby growing in my womb could have positive blood. And because, so what can happen is, the first time I have a baby with Rh positive blood, I don't have any antibodies to Rh positive, to positive blood factor blood. But when the baby's born, there's a mingling of blood between the mom and the baby. So some of the baby's blood can get into my bloodstream, which means that I can have Rh positive blood floating around in my body, which means that I can develop antibodies to Rh positive blood. So we call that Rh sensitization. I create this antibody. So the first time I have an Rh positive baby, it's fine. But subsequent pregnancies with an Rh positive baby, if it's an Rh negative baby, it's fine. But subsequent pregnancies with an Rh positive means that these immunoglobulins, these antibodies, will cross over the placenta and they will attack the baby's blood because they will see that as being a foreign factor. So it's used to be a huge problem because they didn't know what was causing it. This would cause some serious complications. I mean, it was not always fatal to fetus, but it could be. But even when during childbirth, it could cause problems for the baby. My great uncle. My uncle was blue baby. He was born, they didn't realize this problem with the Rh factor, or my grandmother's obstetrician didn't take it seriously. Didn't believe in that mumbo jumbo. So when he was born, they stuck him full of immunosuppressive stuff. They stopped the reaction that was caused by this Rh sensitization attacking his bloodstream. So they rescued him. They rescued him as a baby, and they can still do that, but which is great. But now they don't have to. There's actually serum that they give you, that they give Rh negative moms, that will prevent us from developing antibodies to Rh positive blood in the first place. So it's called Rogram, I think. And it basically stops your body from becoming sensitized to Rh factor, which is good. It's a shot in the bum, and let me tell you, after giving birth, it's kind of undignified to get a shot in the bum, but it's for a good cause. So, so that said, I hope that was not too rambling, and that you understood what I was saying there. I can understand why there would be confusion about blood types changing, but developing antibodies to Rh factor is not the same thing as becoming Rh positive. It means that you're positive for the antibody. So that's what Rh sensitivity is. As far as I know, I'm not, so that's good. I'm done having children anyway, so that all works out. Anyway, and also, I hope that also explains why it's not a problem if you have a different blood type than your child, because that was something that I had wondered about too. That if I have AB, so that's fine. But what if you were type O and you had a type A baby? Shouldn't you develop? Shouldn't you have antibodies to type A baby then? But you don't, because those antibodies wouldn't cross the barrier between you and the child, you and the fetus. Anyway, that's all. I hope you found that informative and interesting, and I'll see you again next time.